This is Data Analytics for Accounting, Lab 5.1, using generative AI to generate summary statistics. In this lab, we are going to upload a ledger dataset, and we're going to convert it to the audit data standards, and then try and understand the basic statistical features of the data. Here we're using ChatGPT, and the Plus version is going to allow us to work with larger data sets. If we come in here, the first thing we want to do is understand the data itself and that transformation process. So we'll go ahead and copy and paste our first prompt, which is how do we transform data from the format our clients give us to a common data model that we can use in data analytics. Now, the response here that we're looking for is a general ETL process, meaning what is the model that we want to compare it to, and how do we transform the data so that it matches that model. It's going to look at some of the limitations with the data, field mappings to get from one to the other, and understanding the business rules. Notice that your responses will probably look different from this because generative AI is going to generate different responses each time. From here, once we have an understanding of the ETL process, we want to compare it to a specific data model. It asks us to specify what we want to compare it to. So we'll put in our second prompt here, and we want to review the AICPA's audit data standards for the procure to pay ledger. This is the purchasing process, and then give an overview of the purchase order table. Now, ChatGPT may already understand what this is, but if we want to be more specific, we'll click on the Add Files here, and we'll throw a web search on here so that it can specifically look at the AICPA's table and pull that in. Go ahead and process that prompt. It will search the web for us, and now it's going to give us an overview of the audit data standard. Here we're going to look at the purpose of the audit data standard, what major tables they include, and then a breakdown of some of the key fields and figures that they see within this. Now that we have an understanding of the table and the format that we want to work with, we are going to start applying this to our own data set. So from our data file download, we're going to drag in our DAA Lab 5.1 GenAI data. This is, again, purchasing data from a company. And for our third prompt, we want it to understand or give us an overview of the data itself. So briefly describe the structure of this data. So you'll see a preview of the data set here. We've got calendar year and agencies. And now it's telling us that it's a table format. It has a primary key, some core attributes like date and amount, as well as some foreign keys that link to suppliers and employee IDs. We look at some of the structure and basically is giving us some overview. We could ask some follow-up questions here if this doesn't provide specifically what we're looking for. Now, we want to get to the transformation process. Here we have the audit data standards, and we could have it try to infer the specific names of the fields and rows within the audit data standard. But because I'm looking for a very specific process and I want it to give me a precise answer, I'm going to give it a prompt where I want it to visualize mapping this data to the standard using these specific features. So from the data standard, we have business unit code, description, product line, local amount, account name, date, and so forth. And so we want to see how this will map from the current structure into this structure. So now we're going to see how it translates the data from the existing structure into the common data format. Because this requires a little bit more logic, it's going to bring in its to help understand the process that it's looking for. This process may take a little bit of time. And if you expand the analysis while it's thinking, it's going to show you that it's generating Python code behind the scenes to take that source data, and it's mapping each of these different source data fields to the audit data standard fields here already. So it's going through and it's generating all of that code in the background, and then it's going to create a visualization. So it's looking for a box plot to show us how they all map together like this. So here we can see the mapping between the two. And most importantly, we're seeing the mapping between the original field agency number to business unit code and so forth. And then we're looking at a bit of harmonization. So it's saying there are some issues with the data that you'll want to keep track of. But essentially, this is the combination that we're looking at. Agency number becomes business unit code and so forth. Now that we've generated that mapping, we can start transforming the data. So for our next prompt, we're going to ask it to transform the data, where we'll take the source data, map it to that standard, and then we're going to tell it to fill in some of these blanks, these proxies or weak proxy values or missing values. So for example, we want the first initial last name that it did figure out was going to be our entered by. We want to set the currency to US dollars, USD, because that is missing in the source up here. And we want to set the fiscal year to 2025 not the calendar year, because the fiscal year straddles multiple years. Go ahead and run that. And what it will do here is now it's going to use that same Python code to convert the data set itself into the format that we can use for any of our analysis based on the AICPA's Autodata standard. So this will take a few moments for it to transform the data. Another really important thing to note here is that the code that it is generating, the Python code it's creating in the background, can be used outside of ChatGPT if we ever need to transform a similar data set. We don't necessarily have to go through all these steps every time with a new data set. We use that code to run outside again. Here they have the downloaded transformed dataset. We can download this and take a look. And now that we have this format, we can start getting some understanding of the basic data. So we want to ask it how many rows are in the dataset and what is the total purchase order amount. A pretty simple statistical calculation. So here we can see the total number of rows and the total purchase order amount. You could use these to validate your dataset and make sure that nothing is missing. Now we're ready to start performing the analysis. Once we have this data, we can start calculating some more interesting things. For example, if we want to calculate the total purchase amount for Oklahoma State University in the dataset and find out which user made the most purchases and are there any transactions that are outliers or anomalies. Again, this may take a few moments to calculate. So now we start seeing the total purchase amount in terms of number of transactions and total purchase amount in dollars. We have the user with the most purchases and their total purchase amount, as well as outliers looking at items that are within the interquartile range or above the interquartile range threshold. There are 819 of these that may warrant additional review. It says here are some potential issues that you can look at. And then it gives us some suggestions on how to take our next steps here. If we want to visualize this, we can ask it to create a box plot. So our next prompt is going to have us make a box prompt. So our next prompt will have it makes a, so for our next prompt, prompt number 8, we want to make a box plot and a histogram of these transactions. Again, there's a lot of calculation going on behind the scenes because it has to program these different visualizations using Python. So it may take a moment to load. Right, here we have our histogram of purchases showing the purchase amounts near zero and so forth. We also have a box plot showing most of the transactions and the ones that are outside of range for Oklahoma State University. Again, because these are all relatively clustered here, it makes a suggestion here that we might want to consider a log scale histogram that would expand out these transactions and focus a little bit more on the volume closer to zero. But we're going to go ahead and continue with prompt number 9. We want to, in this case, create a horizontal bar chart showing the top 10 categories by purchase order amount in descending order. Notice that in these cases, we're using natural language to describe what we want to create using the data. We still have to understand the data enough to decide what we want to show in that bar chart. Okay, so here are our top 10 categories. We can see that airfare is our biggest expense, followed by bookstores and lab dental, and then moving on down the line. Here's also a table format that we can look at with the actual numbers and some observations, what it's trying to describe the data using. We'll put in our next prompt, and here we want to create a vertically stacked bar chart showing the total purchases by day, by category. So now again, we're getting a little bit more granular inside this. This one might be a little bit messy, so we may need to refine this prompt a little bit more if we're looking at a specific time period or if we're looking at a specific category that we want to focus on. All right. So again, a little bit condensed here, but we can see, since this is following a month pattern, we can see the 4.5 weeks of data. It shows relatively cyclical data between these two. And you can see the different categories. Again, American Airlines, the big blue bars in each of these bar charts. So it can show us spikes and seasonality on these different things. Let's create another visual. Our next prompt, we want to create a tree map diagram showing the total purchase amount for the top 10 supplier groups for OSU. So a tree map diagram is going to show the categories, or the suppliers, I should say. So a tree map diagram is going to show the suppliers in their relative size. So the biggest suppliers will be the bigger squares going down to the little ones. Okay, so here we have our bar chart. It didn't like my tree map diagram, so it's showing it as a bar chart instead, which we had before. And it says, if it were going to be a tree map, here's what we would do. Obviously, it's showing the largest supplier. But again, we want to try this again. We're going to try updating this and seeing if it will give us a better visual. Some of these more advanced visualization tools require a little bit of finessing. So here we go. Now we have a second response that's creating that tree map diagram. In this case, ChatGPT is having me compare two different responses to say which one I prefer. When we come down here, we'll click, I prefer this response. And now we can see it's a little bit messy, but we can see here we have American Airlines as our big category, and we can see the different restaurants that we are working with here. If we switch to an interactive chart, that puts those in larger categories. Again, you'll want to go through this a few different times to create a tree map diagram that's going to be visually useful for you. After we've gone through and created some tree map diagrams, the final step is to communicate the results. So now we want to take this and we want to create a list of summaries of key insights. So we talked about outliers, we talked about large purchases. So now we want to focus on the auditor as our audience, and it's going to tell us here's what we have. The overall spending is here, the average transaction size. This means that we have a lot of small transactions with large purchases, which is pretty typical. We have a highly skewed distribution of purchases, most purchases, but there's a small number of very disproportionate high amounts. Here we have our threshold for outliers, as well as transactions that we're interested in looking at. We may want to consider reviewing those 819 transactions that are above the threshold. We have the top spending categories. Again, we want to review our policy for things like airlines and travel. And again, we have individuals who are large spenders. These are our purchasing managers who have responsibility. We want to make sure that they have the appropriate level of authorization and supporting documentation, and whether they are actually buying things that are following their job responsibility. We looked at daily spend tracking, as well as potential risk indicators. And here's our recommendation for the auditors. So this helps us to start putting together the assessment for this lab and understand what's going on. Once you've done this, go back and take some screenshots of your lab, answer the objective questions and analysis questions, and then you can continue on and compare this to how the traditional tools like Power BI and Tableau create similar results. And that concludes this lab.